Hello and welcome. Today we're going to answer this question: which is best, a linear or binary search? So let's say person A thinks of a number between 1 and 100. Person B tries to guess it. What approach could you take? Does it work? Could you simply guess the number and hope that you're right? You've got a 1 in 100 chance to get it right. Another approach could be the halving algorithm. Let's say I pick a number, 24. You could ask a series of questions to guess my number. Is it more than 50? No. So what does this tell us? Is it more than 25? No. What do we know now? Is it more than 13? Yeah. What do we know? More than 19? Yeah. Now what? More than 22? Yeah. Now what? Is it more than 24? No. It's equal. That's the number you were looking for. Let's look at the linear search. My target is 3, and my list there is 4, 6, 1, 3, 4, and 7. So I want to find 3 in that list. So what a linear search will do is look through each one at a time till it finds its target. There it's found its target and the iteration can stop. With a binary search, we take a slightly different approach. Our target is 22, and here's our list of items. Look at that list and consider what you notice there. How many items are in the list? Is it an odd or even number of items? What do we notice about the way the items are? Are they in order? So my target is 22. So I start in the middle of the list here. 31. Now, I can say that every number to the right of 31 can be discounted because as you've noticed, each item is in order. Smallest on the left to largest on the right. So I can discount every item to the right of 31, including 31. So already I've discounted over half of that list. I go to the middle here. 11 is half of 22, so I can discount all numbers to the left of 11, including 11 itself. Go to the middle here. 17. Again, discount 17 and 15 because they're all smaller than 22. Finally, I reach my target of 22. So as you've seen, we need to have the numbers in order and we need to have an odd number of numbers. Otherwise, we haven't got a starting point. Here's an example question. A programmer wants to implement the search algorithm to use with small arrays. Figure 1 shows the example array. So there's my list there of 7 items, and that is considered a small list. Using figure 1, explain how linear search would search for the integer 15. So what it's going to do is going to look through each item individually. It's going to iterate through each item in the list. Found will be set to false initially. Once it's found the item, the iteration can stop and found is set to true. So in your answer, you need to use the following words: element, array, boolean, value, iteration. Think about what these words mean. Iteration is a loop. Boolean is true or false. Array is my list. Element is the elements in the list. And value is the item I want to find. The search begins with the first element, or 4. The element is compared to the value being searched for, 15. The search iterates over each of the elements sequentially. If the element in the array does not match the value being searched for, then the iteration continues. The search returns the position of the element if the value is found in the array. A Boolean flag is set to true if the value is found. Now, it's important to note that to reach at least a grade 5 or C equivalent, you must be able to demonstrate that not only do you understand the two methods, but you can compare them. And this is true of any example that you're taking. With my linear search, it works. It's going to find the item if it exists in the list, because it's looking through each item sequentially. The items don't need to be in order. Negatives, it's slow, and for larger lists, it would be inefficient. It wouldn't work as well. It would find the item, but it would do it much more slowly. Whereas the binary search is fast. Certainly much quicker than linear search for larger lists. It's more efficient with large amounts of numbers. Negatives include numbers have to be in order, as we noted before, and there must be an odd amount of numbers in the list for it to work. Now, for smaller lists, it doesn't actually matter. Both of these search methods would find the item in a similar amount of time. But for larger lists, definitely the binary search would be a lot faster. So that concludes the video. Please consider liking and subscribing if I've helped you. And I say a big thank you for watching, and I will see you in the next video. Bye bye.